Hey everyone, I'm Gautam Raj, a game developer. In this video, I'm going to show you how I created a hand IK system in Unity that lets the character touch walls and nearby objects using animation rigging package. It works by detecting walls near the character and smoothly blending IK weight to position the hands naturally against those surfaces. If you haven't seen my previous video on foot IK, feel free to check that out. I explained how to make feet adjust dynamically to uneven terrain using similar rigging techniques. Now, same as I have explained in my previous video, I have another rig layer called hand rig layer. Under that, I have two game objects, one for left hand IK and another for right hand IK. If I go under left hand IK, I have target for left hand and hint for left hand, and another game object for controlling the rotation of the palm. So here you can see in hand rig layer, I have the rig component attached. Under that, in on left hand IK, I have two bone IK constraint attached. So here in the target, I have passed the target game object, and here in the hint, I have passed the hint game object, and I have passed all the required bones um, on tip, mid, and root. Same goes for the right hand IK. Now to detect the environment, I have created another game object called environment interaction. Upon that, I have added box collider with is trigger on, then rigid body with is kinematic on. Then I have created a script called environment interaction where I have passed the animator controller of the character. Then I'll explain what I've done inside the environment interaction. Now here you can see the script of environment interaction, a monobehavior script, which is containing on trigger enter, on trigger exit, on trigger stay. So in every trigger function, you can see I'm checking the other collider is part of our environment layer or not. If it is a part of environment layer, then I am proceeding towards the functions which I have declared inside player animator controller. One is start trigger environment touch. So whenever the trigger enters, it will trigger this function. Then inside on trigger exit, I'm calling in target environment touch. Then inside on trigger stay, I'm calling update target environment touch. Let's start by looking at how we trigger the environment touch system. I have created these three public methods here: start trigger environment touch, update trigger environment touch, and end trigger environment touch. These are meant to be called when character being touching, continuous touching, and stops touching the environment. Each of these methods take a collider as parameter. This represents the object in the environment the character is interacting with. It could be wall, pillar, or any other surface. Inside each method, we call a function named getClosestPoint and apply IK. And we pass two things, the collider and the position of the character's neck bone. This is important because we want to calculate the closest point on the collider relative to the upper body so the hand can reach out in a realistic way. In the end trigger environment touch method, I also make sure to reset the is left hand touching to wall and is right hand touching to wall flags, which are used to stop applying IK weights after the touch ends. Now let's dive into the main logic that powers our hand interaction. The get closest point and apply IK method. This function takes a collider and a body position, which we were usually passing as the neck bone position. The goal is to find the closest point in the collider relative to the upper body and then determine if the left or right hand should react. First, we use closest point to find the nearest point on the collider to the body. It tells us where the wall or the object we might want the hand to reach towards. Then we determine which side of the body, left or right, is actually closer to the contact point. This is done by comparing the distance from the point to each soldier. Based on this check, we set is left hand touching to wall or is right hand touching to wall flag accordingly. Now here, we don't want the character randomly stick their hand out just because there is a collider nearby. So we calculate the direction from the neck to the touch point and use the dot product to check how forward facing that point is. If the dot product is too low, meaning the surface is behind the character, or too high, meaning it's straight ahead, at that time we cancel the touch. This helps to avoid awkward or unnatural IK placement. I also make sure the surface is within a specific distance range using min and max wingspan values. This keeps the hands from stretching too far or reaching too close to the body. Finally, if the direction or distance isn't within acceptable bounds, we reset the touch flags to prevent any IK from being applied. So this is the Bucks collider as you have already seen. This helps me to detect the environment, and here I am setting the max wingspan and the min wingspan. Then here you can see the white color sphere upon the wall, which is the contact point for the character, or we can say the nearest contact point. Currently it's behind the character, so that's why the character is not putting hands upon it. If I just rotate it a little bit, so you can see the character is taking and trying to put the hand upon the white circle. Now that I have determined which hand should interact with the environment, it's time to blend the actual IK using animation rigging constraints. That's exactly what I'm doing in this method. Put hand on wall. First I check if the hand touch interaction is allowed. This gives me an easy toggle to enable or disable system globally. It's super useful for testing or conditional logic in gameplay. Then I define a dynamic max hand weight. If touch point is further away, I reduce the max IK influence slightly to avoid overreaching. If it's too close, I allow a stronger connection. This section handles the left hand. If it's marked as touching, I gradually increase the IK weight using left so the hand reaches out smoothly. If the interaction ends, it reduces the weight gradually to make the hand return back naturally. Here I applied the updated weight to the actual constraints, the 2-bone IK for hand positioning and a separate multi-rotation constraint for the palm. I also do a simple threshold check. If the weight is too low, I just cut off it entirely to avoid twitching. The logic for the right hand works exactly the same, smooth blending in and out depending on the interaction state. Finally, if a hand is touching to the wall, I update the IK position to the closest point I calculated earlier. This ensures the hand always stays on the correct part of the wall or the object during the interaction. And alright, that's it for this one. Thanks a lot for watching.